Hey everybody, this is Larry. This is me going over Q3, find latest group of size M. So this is actually a tricky problem. I think the easiest way to do it is by simulation. So the first thing to notice with simulation is that notice the n. So n is going to be 10 to the fifth, which is 100,000. So a really naive simulation is probably going to be n squared. So we have to figure out how to do better than n squared with simulation, right? So the way that I solved this problem, and I think I knew how to do this immediately, so I don't really have insight into how to think about it. But I think the way that I thought about it was, okay, I need to simulate. The best way to do this is just by simulation, and we need a way to kind of merge these groups together, like all these. I'm looking at step 2 here, and then when you put this one here, you merge two groups of ones, right? In step 4, and then it's just a lot of bookkeeping, a lot of things to track, and from that I know that if we want to simulate, like if you do a naive simulation and this merging step takes O of n, then it's going to be n squared. But we could get it down to O of 1, or Ackermann's constant, or reverse Ackermann's constant, or inverse reverse Ackermann's constant, something like that, effectively constant, then we can have a good time. Or even log n, then it would just be n log n, but that's fine. But union find in different implementation, you can do that. So I end up doing union find because I look at these ones, it's just merging to the left and merging to the right, and then whatever that they're connected to, and then just kind of keep track of a lot of things. I know that I'm hand wavy a little bit on keeping track of a lot of things. We'll go through the code together so that you can understand what we're keeping track of. So first, these are my union find operations. Usually I only implement the union and the find, but in this case, it seemed to make sense that I also keep track of the size because, well, we have to keep track of the size. So then I just implemented the size tracker. I actually don't do the merge by rank or by size because I was a little bit lazy, and usually it's not super necessary as long as you have path compression. Don't take my word on it. Do your own research, play with it, and I also just return the size of a node by getting, the size of the parent. So that so that's kind of how I add a helper function. And then the simulation is just, okay, so for each index, and index is just a time step, right, of the array. So we now simulate from left to right, one step at a time. We look to the left, and if we already used left, then we want to merge it with, or we want to get the size. If we already used the right, meaning that, let's say we're here, look at the left, look at the right. If it's already taken, then you get the size of the left and the size of the right, and then the current size is always going to be 1 because you're just putting it in, right? Current size being the size at x. I know that I did this weird thing here because I just wanted for symmetry reasons, but yeah, so the left is equal to the size of the left. So now we merge them together. So what's the new size? The new size is just the size of the left plus the size of the right plus 1, which is the current size. And then now we know that if you keep track of all the counting, first of all, there's no numbers in the list, but when you put in one number, then it'll be plus 1, right? Because by itself it's just one element, and then you remove it because, well, that's what you remove. And also the left side we subtract by 1. On the right side we also subtract by 1. That's the number of components. And then from this we increment the new size, right? So basically, for example, if you have one element to the left, one element to the right, and you insert 1, then you went from 2 single elements to 3 element, right? It's a new element. So that's kind of the simulation that I have, and also just keeping track of what we used. And then after that, we just have to do a union on the left and a union to the right. And then at the end of each simulation step, we just see, hey, is there a group of size M, right? And if that's true, then we set the, now is the latest time. You could actually probably just set latest is equal to index 1, but I like writing like this just in case sometimes in different problems you may change certain orders, and then this might bite you, but that's how I like to do it. And I know it's a little bit more inefficient, but it's not as you don't need to be that efficient. But that's pretty much it. So simulation plus union find and keeping track of stuff. So you may ask, I think a common question that I may get asked is, well, okay, let me finish the complexity first. But because for each element we do at most 2 union operations and 2 size operations, and let's just say is log n because whatever, then it'll be n log n. But actually, we even do path compression, so the actual complexity will be shorter than that. So roughly between n to n log n, say. So that's the running time complexity. The space complexity is O of n. We have a number of arrays that we use to kind of keep track of stuff. But yeah, so roughly linear time, linear space is the complexity of this problem. And then the question you may ask is, because I get this a lot in problem solving in general, is how much of the union find do I remember? And actually, if, one is if you see me solve it live next, none of this is copy and paste. I just remember it from my head and I just kind of do it. So I do remember the find and the union. And then because I have an understanding, and I don't, if it sounds braggy, I'm sorry, but it's just that like I remember how, what these code means to me, and from that I could just add the size really easily, because I think about these as trees and nodes and stuff like that, right? So, that's what these parents do. So I urge that if you have trouble implementing it, just practice more. It's not impossible. I believe in you, and try to get the understanding as much as you can. But for me, I actually implement this from my head, so I don't have any template or anything, which may be not great for contest timings. But for me, I don't worry about contest timings, and I don't care about rank that much. I know I complain about it, but at least for because I want everything in my head, right? Cool. Yeah, that's all I have for this problem. Watch me solve this live next. Okay. People are really fast. Oh, I need to do the size. This. Let's see. Oh, this is not mine. This is just. Oh, I don't union either, but that's fine. I have a lot of bugs. Why is x -1? Okay. Oh, this is not right. Oh man. Oh, This is not used yet. Man, there must be an easier solution to this, but I'm choking a little bit. Okay. Well, it counts as in the right item. Oh. 2. This is just not right. Okay. Do this. Not confident about this at all, to be honest. Hey everybody, thanks for watching me solve this explain these problems. I have a video for this contest for the screencast. Let me know what you think. Hit the like button, hit the subscribe button, and join me on Discord, ask questions, have fun, and I will see you on next contest. Bye bye.